our lesson for today, the first thing we need to remember is what do we need to get going when we attempt this section. So the first thing we need, definitely a ruler. So when we use our rulers in measurement, especially when we do scale and maps and plans, it's so important to have a ruler that you can clearly see the markings on and that you understand the difference between millimeters and centimeters on your ruler, because measuring accurately is something that is so important when we do scale and then also maps and plans. Secondly, after that, we also need a calculator, very important. And then for today, you also need a copy of the subject workbook for grade 12 mathematical literacy. If you don't have a copy of the subject workbook, you can follow along with me in the lesson. You will still be able to practice the calculations with us, but it would be lovely for you to have a copy of that with you. So the last thing that I'm going to ask you to bring is an open mind. Now, I know that some of you, immediately when you saw that our topic for today was scale and maps, you perhaps thought, I don't like this work, I've never understood this. But if you come with an open mind and a willingness to learn and ways to think about this and maybe to find a different method that you haven't tried yet, you should be able to learn something today. So if we keep our minds open and we start thinking about the concept of scale. So we are so lucky in mathematical literacy that everything is context-based and something that we can relate to real life. So one of the things that I always think of when I'm working with scale, if I think of something like a 5 Rand coin and I want to measure the diameter of my 5 Rand coin, so from this end to this end, you will see that the diameter of a 5 Rand coin is about 26 millimeters. So why are we doing this? Grade 12s, we are doing this to have an understanding of what is 26 millimeters. So if I'm looking at this, okay, this looks more like 28 the way this ruler is placed, but this gives me an idea of if someone says 28 millimeters, you all know how big a 5 Rand coin is. That is more or less that size. But now, when we have to look at centimeters, so just comparing millimeters and centimeters, if I show you a picture of a pizza, then the diameter of this pizza is 26 centimeters. So now, if you have to start thinking, just before we even touch the concept of scale, a 5 Rand coin is 26 millimeters and a pizza is 26 centimeters in diameter. So we can very clearly see that there is a difference between 26 millimeters and 26 centimeters. The same will then obviously apply to meters and kilometers. But this is the type of thinking we need to have when we are going to be working with scale. Now, starting off with scale, we get 2 types of scales that we work with in mathematical literacy. And you need to be able to work with both of these, so identify and work with them. You need to be able to name them, you need to be able to explain them, you need to be able to do calculations with them, and you need to know advantages and disadvantages of each. So if we look at a numerical scale, another word for that or another name for that is also a ratio scale. And if I look at this scale, it is 1:20,000. So that makes sense that it's called a ratio scale because it gives us one number is to another number. And then if we ever are asked to explain this, we will say 1 unit on the map or on the plan represents 20,000 units in real life. So I'm going to explain the meaning of the word units to you in just a few seconds, but it's important for us to know that when we have a numerical scale or a ratio scale, if we want to make sense of this, we need to remember that a ratio scale is always one number to another number, and it's always going to be whatever is on the map to whatever is in real life or reality or on the ground. So many units on the map represents so many units in real life. Now, the next thing that we see is we also have a bar scale. Now, if we look at what we have here, just this graphical representation that we give you, this is a good example of a bar scale. This is a little bit more of a line scale, but it's still classified as a bar scale. Now, what I want to show you rather, while we are doing this is the following. When you are working with a number scale, a numerical scale, or a ratio scale, the scale is already given to you, so you don't have to calculate anything or measure anything on the scale. However, when we get a bar scale, you will need to take your ruler and measure on the given scale to be able to determine how many centimeters on the map will be how many kilometers in real life, and so on. So just to remind you, also, if we look at these two examples that we have here, it can be a measurement. In this case, when we use a bar scale, we can be working with something is to so many kilometers or something is to so many miles. So we need to remember that when we are working with a bar scale, we can be working with two different types of measuring units, and we need to be aware of that. So in summary, we get two types of scales, numerical or ratio scales and bar scales. And obviously in this lesson, we will spend some time focusing on doing calculations with these types of scales. But this is a nice introduction just to remind you, you need to be able to identify them and explain what they mean. Now, something I've already spoken about quickly was the map distance to the actual distance. So what we wrote here is we wrote map is to real life, which obviously means the map is to the actual. So if we now write 1, it means 1 unit on the map. If I say 1 is to 80, it means 1 unit on the map represents 80 units in reality, in real life. That's the actual distance. So what you need to note immediately is, I keep saying unit, 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 and I don't actually write a unit here. So that means when we are working with a ratio or a number scale, we know that these two units should be the same. That's why I keep saying 1 unit is 80 units, which actually means that 1 millimeter on the map should be the same as 80 millimeters in real life, or 1 centimeter on the map is then the same as 80 centimeters. So it's important to understand that when we have a ratio scale, there won't be units, because it means we are now fully assuming that whatever's on the left is the same as what is on the right. So grade 12s, I hope that this makes sense, and it will help you when we start looking at the questions in just a few minutes. So there you can just see another example where that is explained. Now, I've told you how it works, how to express it in words, how to identify them. But of course, in mathematical literacy, most of our time will be spent doing the sums. So how are we going to use our scale? First of all, we need to look at the type of relationship. So when it's in a unit ratio, 1 is to something, something, something. We know it's a unit ratio because there's a 1 on the left-hand side. So now once we have the type of relationship that we use for scale, we must remember that we have no unit. So if it's 1 is to 20,000, it means 1 unit on the map is 20,000 units in real life. So first we identify the type of relationship, then we make sure that there's no units so that we know that left and right we have the same unit. Then we should convert. Now you'll see here, we need to remember that the most suitable units of measurements of length or distance in reality is normally meters or kilometers, which we will have to convert from centimeters perhaps to meters, or millimeters to meters, and so on. Now, this is given to you where they ask us to know that from kilometers to centimeters, we must multiply by 100,000, and from centimeters to kilometers, we must divide by 100,000. But before we get to that, let me just remind you of something that you would have seen from grade 10. And I wrote this down for us before I started, just to remind you. Yes, you have to know this. We have to know conversions of distance or length within the metric system. So we need to know to go from millimeters to centimeters, I divide by 10. From centimeters to meters, divide 100. And from meters to kilometers, I divide 1,000. So just to go back to what our previous example said, if I have to then go from centimeters to kilometers, so from centimeters to meters, I will divide by 100, and then I will divide by 1,000 to go from meters to kilometers. And that is why on the PowerPoint it actually says divide by 100,000. So you can either take the distance in centimeters, divide by 100, and then divide by 1,000, or divide by 100,000. You are going to get the same marks, and you are going to get to the same answer. What is important is that you remember this, because this will not be given to you. It is expected that you will know this. So, now that we have a better idea of what is expected, we need to start looking at the types of questions they can ask us. So, there's normally 3 types of questions that they ask us when they ask us scale calculations. The first one would be, we have the scale, we have the map distance, and they are asking us the actual distance, or the distance in real life. Now we can look at our first example. So, the question is saying, use the given numerical scale to calculate the actual length if the map distance is 20 centimeters. And then they give us the ratio, 1:20,000. So, when we start attempting a question like this, we need to make sure that we work with what is given, and we need to work with what they are asking us. So what is given in this case is the distance on the map, and they tell us that is 20 centimeters, and the scale, and the scale is 1:20,000. And what they are asking us is to give the distance in reality. Now, a nice easy way for us to remember this is just to go back to basics. So if we remember, when we have a scale, it is map on the left-hand side and real life or actual distance on the right-hand side. Then I write down the scale if the scale is given. In this case, we were lucky. The scale was given. 1:20,000. So 1 unit on the map is 20,000 units in real life. Now, the next thing that is given is a map distance of 20 centimeters. So in other words, map and map goes together, and real life goes together. So map will be 20, and real life is the thing that we are being asked. We don't know what it would be in real life. So then if we use the magic method, we see we have 4 things of which one is unknown. So I will divide up and multiply across. So therefore, 20 divide by 1, we should know that will give us 20 times 20,000, which is the scale. Now, we can do this on the calculator, and you guys can see I brought a basic calculator with, just to remind you that we don't need a fancy calculator. We just need to know how to use it. So 20 divided by 1 times 20,000, that gives me an answer of 400,000. Now what we need to remember is if this is 400,000, there's another way that you can get to this. So if you look at this, I just want to show you a different way. So what you can do now is you can also see the ratio is 1 is to 20,000. 20 centimeters is to the actual distance. So here what they did is they did 1 divide by 20, where we said 20 divided by 1 is the 2,000 centimeters. So if we just go back to what we have here, 1 unit on the map is equal to 20,000 units in real life. So 20 units on the map will be equal to how many units in real life? So 20 divided by 1 times the 20,000. So just to remind you, we said 20 times then the 20,000. So the scale factor gave me 400,000. Now, we don't have a unit here, but we know we need to have a unit. So if we have a unit here, we know that this will be in centimeters. And we know that this is in centimeters because this was given in centimeters. So therefore, we can now convert from centimeters to meters or kilometers, depending on what the question is asking. Now, so we've now practiced if they give us the map and we need to go to real life. So what you need to remember is if you think about a map of your school, even a plan of your school, and real life, you know it is going to be, the map is going to be a small picture. Let's say your classroom might be this big on the map, but in real life your classroom is actually big enough to fit 40 or something learners. So normally when we go from a distance on the map to a distance in real life, we will multiply by the scale factor. So that's just important to remember. That was the first one that we looked at. Now, the second type of calculation we need to look at is going to be the scale is given, the actual distance is given, and we need to go back to the map distance. So now, let's look at the question. Use a given numerical scale to calculate the map distance if the actual distance is 2 kilometers. And the scale they give us is 1 is to 20,000. So if 1 is to 20,000, we know that this is map and this is reality. So we have our scale factor here that's given. And now we must see what was given to us, map distance or real distance. If I go, I can see on my PowerPoint here, the actual distance was given. So here I've got the 2 kilometers. So now I need to figure out if it's 2 kilometers in reality and the scale is 1 is to 20,000, what would this distance on the map be? Now, we need to remember that a map is going to, as I said earlier, is going to show your classroom as this big. So it's probably not going to show your classroom in kilometers, the drawing. It will probably be centimeters or millimeters. So now, just as a precautionary measure, I'm going to say, okay, 2 kilometers would be how many centimeters? So if I have to look at something like this, I can say, just for myself, if 2 kilometers is in real life, how many centimeters is that? So to go from kilometers to meters, I will multiply 1,000, and to go from meters to centimeters, I will multiply by 100. So 2 times 1,000 times 100 in this case will give me 200,000 centimeters. So note, I haven't done any calculation with the scale. All I did is, in my mind, I remembered, normally on a map, I measure in millimeters or centimeters. So I'm just trying to make it easier for myself when I get to that step of the question. So if I have 1:20,000 and I have 2 kilometers here, it means the same as 1:20,000. My scale is still the same. But now my distance in centimeters instead of in kilometers is going to be 200,000 centimeters. And now from here, I can determine how many centimeters it will be on the map. So remember, grade 12s, if we do the magic method, what we will need to do is we will need to see, this is what I'm missing, the map distance. So I will divide up and multiply across. So in other words, I always need to still write out what I'm doing. So 200,000 divide by 20,000 times 1. So if I say 200,000 divide by 20,000 times 1, I get an answer of 10 centimeters, which means that if I have 2 kilometers in real life, I will draw it on the map using 10 centimeters of space, because this thing in real life that is 2 kilometers long has now been reduced 20,000 times to give me the length that it's showing on the map. So if you think about this, I said, if we go from real life to a map, we're probably going to see now it's going to go from the 2 kilometers to a 10 centimeters. So it's going to go from bigger to smaller when we go from real life to the map distance. So in this case, when we go from reality to the map distance, it is important that we divide by the scale factor. So what do you see here? Here I wrote, if we go from map to real life, we multiply by the scale. Now I said if we go from real life to the map, we divide by the scale. So those are the first 2 types of calculations. And now if we look at the third type of calculation, you will see the third type will now be the map distance is given, the actual distance is given, but the thing that's not given to us is the scale. And now we will need to be able to calculate the scale using those 2 things that are provided. So let's look at the example. 4 centimeters on the map represents 10 kilometers in reality. Therefore, determine the scale of the map. Now, we need to make sure that we feel confident in the method that we follow. So we need to remember, when we write a scale, it's normally the map or the plan distance to reality. What we also need to remember is no units, which means we must work in the same units. So if we go back to the question, it says 4 centimeters on the map represents 10 kilometers in reality. So 4 centimeters is equal to 10 kilometers. But now I told you no units, which means I can't leave this as is. I now need to say, if I'm going to rather work in centimeters, so the 4 stays the 4, but now I will need to convert this kilometer also into centimeters. So remember to go from kilometers to meters. I will multiply by 1,000, and then from meters to centimeters, I will multiply by 100, or you can just multiply by 100,000 from the get-go. And now, if you see, we will get the distance in reality, still the same distance actually, will now be 1 million. So now I don't have two different units anymore. I have centimeters and I have centimeters. So 4 centimeters is the same as 1 million centimeters. So the question asked us for the scale of the map. Remember we said when we determine scale, it needs to be written as a unit ratio. And a unit ratio means the left hand of my ratio, the left-hand side must be 1. So how am I going to go from 4 to 1? It means I have to divide by 4 on this side, and then I must divide by 4 on this side as well. So if I do 1 million, divide by 4, then I get a total of 250,000. So now I have taken what was given, I wrote it in the right order, I converted it to the same unit. If you wanted to convert it to millimeters, you could have done that, or meters, you could have done that too. Then I made sure to write it as a unit ratio by dividing this number by itself and also this number by the same number. And now I have my scale. So that means we can get 3 types of questions based on scale. The first one is to calculate the actual distance using the map distance and the scale. The second type of question is to calculate the map distance using the actual distance and the scale. And the third type is we are given the map distance and the actual distance, and we are now calculating the scale. So I hope that those examples gave you a nice idea of how we are going to approach these questions, because now we are going to jump straight into trying the questions in the learner book. So that's just another example. So if we look at this, we will now see that to use a bar scale, so the whole time I've been using a number scale or a ratio scale with you. But when we start using a bar scale, we need to remember that this that is given here is the actual distance. So we've only done one type of scale. Now we're just going to quickly look at another one. So if we have this, we see that this actual distance is 4 kilometers, which means the map distance I won't be able to say is 1. I will now need to take my ruler and measure. So in this case, if I have a look at this ruler, I would say that 16 centimeters on the map, because the scale is going to be on the map, 16 centimeters on the map is 4 kilometers in real life. So the steps that you would do is step 1, you would measure it. Like I said, now I got 16 centimeters. Then step 2 would be to write it as a ratio. And step 3 would be to convert to the same unit and write in unit ratio. So in other words, what we have here is we have that 16 centimeters, which we measured here, is the same as 4 kilometers in real life. Now to go from kilometers to centimeters, because we want the same unit, we are going to say 4 times 100,000, which gives us 400,000. And then we need to know that to go from, so now we have 16 is to 400,000. But to go into a unit ratio, I'm going to say 16 divided by 16, and then 400,000 divided by 16, which will then give me 25,000. So now I've shown you how to also take a bar scale when it's given to you and convert that into a unit ratio. And once that is in a unit ratio, you can follow the same steps that we've been following. There's obviously other ways that we can also attempt this question, but that's one way of working in a common manner to get to the same answer. So let's go and see how well we understand what we've been doing. So the first question says, The length of the one side of a building is 9.5 meters. The length on the plan of the same side is 4.75 centimeters. Determine the scale in the form 1:2. Now, we always ask ourselves, what is given, what are the units, and what is asked? So, they want us to write the scale. So, what was given is the actual, and the actual was 9.5 meters. And what was also given is the distance on the map, and that was 4.75 centimeters. So what I can already see, we're not working in the same units, so I'll have to convert. So let's say I'm going to convert to centimeters. So to go from meters to centimeters, I'm going to multiply with 100. So if I say 9.5 times 100, I will get 950 centimeters. So I've already now made sure I'm working in the same unit. I've converted accurately, and now I can see they asked me to calculate the scale. So we know scale is distance on the map to distance in reality. So let's plug and play. The distance on the map is 4.75, and then we know that the distance in reality is going to be 950. So we know that this is centimeters and this is centimeters. So therefore, I don't need to write down a unit. And now that I have this, we go back to the question. And the question actually says, determine the scale in the form 1:2. So in a unit form. So how am I going to go from 4.75 to 1? I know I will need to divide by 4.75. And then if I do it on the left-hand side, I must also do it on the right-hand side. So now if I say 950, divide by 4.75, I get a scale of 1:200. So grade 12s, we've now practiced the skill of determining the scale after we explained it. So always look, what was given, how can I convert to the same units, and what is asked. Now, if we look at question 2, again, I'm saying what is given, what are the units, and what is asked. So question 2 says to us that the distance between Wellington and Malmesbury is 44.1 kilometers. So first of all, you need to now figure out for yourselves. If it's 44.1 kilometers, there's no way that they're going to draw a map that is 44.1 kilometers. So this will be the actual distance. Then the length on the plan between the two towns is 18 millimeters. Determine the scale of the plan in the form 1:2. So I just want to show you, while I've got this in front of me, if I look in your workbook, you'll see that here you've got an example of this, and here we've now told you it's 18 millimeters. But on here, they are showing you that from here to here, if I was going to use an actual ruler, I would get 18 millimeters when I measure in a straight line. So I know the real distance is 44.1 kilometers, and I know the distance on the map is 18 millimeters. So once again, what was given? The actual measurement of 44.1 kilometers. What else was given? The map distance of 18 millimeters, and what they asked us to calculate once again is the scale. So now I have a summary for myself. What do I have? What do I need? And immediately I can see millimeters and kilometers. We're not working in the same units. So I'm going to now go from kilometers to meters first, which will be times 1,000, and then from meters to centimeters, which is times 100, and then from centimeters to millimeters, which is times 10. So technically, I'm going to take this and multiply this with 1,000,000, which will give me 44,100,000 millimeters. So now I can see, all right, I've got millimeters and millimeters. So from here, I should be able to attempt this question. So another thing that you could have done is you could have converted this to meters, or you could have converted both to centimeters, as long as you are working in the same units. So now we know the scale is asked. We know we need to go from the map to reality. And if we now look, our map distance is 18. Our actual distance in reality is 44,100,000. I know I'm working in the same units, so I have done that part. And then they ask me in the form of 1 is to something. So to go from 18 to 1, I'll divide by 18. And that means I'll divide by 18 on this side as well. So if I take my 44, just to show you how I got to that, the 44,100,000. And if I now take that and I divide that by 18, I get an answer of 245,000. So 2,450,000. So what you can see is in your answer book, there's perhaps a slightly different method. But what I'm showing you is if I go millimeters on either side, or meters on either side, or centimeters on either side, I'm going to get to the same answer. So let's move on to question 3. Question 3 says, given a scale, so now I know I'm not going to determine the scale. I already have the scale. So given a scale of 1 is to 250, the measured length is 10 centimeters. Calculate the actual distance in meters. So the scale is given. The scale is 1 is to 250. I know that this is the map or the measured, and this is real life. See how I always write this for myself just to remind me. Now I go back and I check what was given to me. It says that the measured length is 10 centimeters. So in other words, I know this must go under measured or map, because you measure on the map, and it means we don't know what the real life distance is. So as we said earlier, we can use the magic method where we divide up and multiply across. So in this case, it would be 10 divided by 1, which will be 10, times the scale factor, which is 250. Remember, we said when we go from map to real life, we will multiply by the scale factor because it's going to be bigger in real life. So 10 divided by 1 times 250 would be 10 divided by 1 times 250 gives me 2,500 in real life. But 2,500 what? We go back to the question. The question said the measured length was 10 centimeters. So now I know if 10 centimeters is on this side, it means this will be 2,500 centimeters. Now, what you need to remember, grade 12s, is even though this question is telling you what unit to work in, we also know that normally we won't tell someone, yes, my house is 2,500 centimeters away from my neighbor's house. We will be saying, oh, it's so many meters or so many kilometers. So luckily for us, this question asked us for the actual distance in meters. But we also need to be able to use a little bit of logic to get to that. So the question asked in meters, we currently have centimeters, so we know we will get a mark for going from centimeters to meters, which means I must now divide by 100, And now I get an actual distance between these two places of 25 meters. So grade 12s, see how we are looking at the method and we are consistently applying the same techniques to get to our answers. If we look at question 4 says the measured distance is 280 millimeters and the actual distance is 15 kilometers. Determine the scale of the map in the form 1:2 and round off your answer to the nearest 1,000. So what is given? The map distance as well as the actual distance. The units are millimeters and kilometers, so we know we're going to have to make sure we work in the same units. And then what is asked? We are asked to determine the scale, and then we are given a bonus instruction of making sure we are rounding correctly. So let's go back. Instead of going straight into millimeters this time, I'm going to say, okay, if the map distance is 280 millimeters and the real distance is 15 kilometers, I'm going to decide that I want to work in centimeters. So to go from millimeters to centimeters, I must divide by 10. This now gives me 28 centimeters. To go from kilometers to meters, I must times by 1,000. And then from meters to centimeters, I must times by 100, which is now actually 100,000. So 15 times 100,000. And you can definitely use your calculator. It's not going to be anything bad if you do. And you will now see you will get 1.5 million. And what do we know? Both of our values that we have now are in centimeters. Because my units are the same, I know that now I can go into my map calculation of saying, when I have a scale, I have map to real life. On this map, I have 28 units, and in real life, I have 1.5 million units. I know I'm working with the same units, so I'm good to go. And now what I need to do is I need to write as a unit ratio. So that means to go from this to this, I divide by 28, and I divide my 1.5 million by 28. 2, and when I do that, I now get 53,571,43. But we go back to our question where we had a specific rounding instruction. Round off your answer to the nearest 1,000. So in other words, I'm going to look at my 500 to see what will happen to my 1,000. So I know rounded off, I'm going to have 1:54,000. So if you think about it, this one will be more accurate than this one. But this is much easier to read and then to work with when we start doing these types of questions. So we've been practicing how to go from map to real life, from real life to map, and how to calculate the scale. Those were the 3 types of questions we mentioned, and therefore those are the 3 types of questions we've been calculating. So if we now decide to do a few bonus questions, because all that I've been given you is question on question using the ratio scale or the number scale. So if we do some bonus questions on bar scales, you will find them also in your learner booklet. Now what we'll see is the scale is given. If you look at this example, it says the length on the map between 2 towns is 4 centimeters. So they've measured something on a map. Calculate the actual distance in kilometers between the towns using the given scale. Now, remember what we said. When we have a bar scale, we can't just write down the scale and go. We have to first take our ruler, measure the bar scale, figure out what it means, and then we can do our calculation. So, if I look at this bar scale that's given, I can see here that 2.5 centimeters on my map or on my plan is going to be the same as 150 kilometers in real life. So I must write this down for myself. 2.5 centimeters on the map, because I'm measuring on the map, is going to be the same as 150 kilometers in real life. But now I can already see there's so many things that are different in this question. So what do I know now? There's centimeters and there's kilometers. So you can either take this into a unit ratio, so then you can make a scale by making them into the same level, or if we go back to the example, it says the length on the map between two towns is 4 centimeters. So in other words, what is given to us? Given to us is a scale, which we now have. I know it's different units, but it's not a ratio scale. So it's there, and then what they also gave us is the distance on the map between two places being 4 centimeters, and asking you how many kilometers is that in real life. So you can convert it all to a unit ratio scale and then work from there. But we can see here, these are actually the same units. So we should be fine if we follow our magic method where we've got map and map, real life and real life. So I'm going to divide up and I'm going to multiply across. So now I know 4 divided by 2.5 times 150. So if I do this, 4 divided 2.5 times 150 gives me an answer of 240 kilometers. So using our magic method, we could figure this out without first making a unit ratio scale. But you still need to understand how this works. It's giving us a ratio of saying so many centimeters on the map is so many centimeters, or so many kilometers in this case, in real life. So then when we have centimeters on the map, we can use that scale to calculate the actual distance. So if we look at the next question, question 1 says, given the plan and the scale below, they give us the measured length being 15 centimeters. We know that is the length on the map. And they ask us to calculate the actual distance in kilometers. So if I look at this scale, now I can see, if I read from here, I'll see that 2 centimeters over here is going to be equal to 150 kilometers. So if I write it down for myself again, I will see that in this case, the map to real life, on the map I measured 2 centimeters is equal to 150 kilometers. So because 2 centimeters is equal to 150 kilometers, if I go back to my question, it's saying the measured length is 15 centimeters. So measured on the map, 15 centimeters is going to be how many kilometers? And now you know, because I'm lazy, I'm just going to use my magic method where I divide up and multiply across. So therefore it's going to be 15 divided by 2 times 150, and that's going to give me my answer in kilometers of 1,125 kilometers. So actually, when we think about these types of calculations, when we work with a unit ratio scale or a ratio scale, or a number scale, we are working in the same unit. But when we are using a given bar scale with two different units of measurement, and we can apply that in this context, we will say something like 2 centimeters is equal to 150 kilometers. And then I can use the centimeters on the map just to go straight into kilometers as well, because this is already telling us this is equal to that. So if we look at the last question, and I just want to spend some time showing you how we can approach this kind of question. So if we look at this question, we can see that here we have different questions being asked, and I'm not going to go through all the questions. I want to jump straight into this question. So if we look here, we've been practicing today using scales and calculating map to real life to map, and so on. But we need to remember, in your exam, you are probably going to get your map and then your scale. So we're not just going to give you questions on scale in isolation necessarily. We're going to probably be asking you to use a scale in a given context of a map or a plan. So if we look at this last question, it says, use the scale, calculate the scale used on the map in the form of 1:2, and then it's ... So now we need to do one last calculation in context to make sure we feel comfortable. So let's remember, if they want it to be in the form 1:2, it means whatever we measure on the map needs to be to real life. Now, let's see. What I see here is a bar scale, and it goes from 0 to 500 kilometers. So the first thing you will need to do is you will need to take your ruler and you will need to measure this bar to find the actual length. And when you measure that to get the actual length, you should get 2 centimeters, which means 2 centimeters on the map represents 500 kilometers in real life. So now I can write this in for myself. I know that 2 centimeters on the map represents 500 kilometers in real life. But this is not going to be a unit ratio because it's centimeters and kilometers. So we must make sure we have the same units. So to go from kilometers to centimeters, I know I must times by 1,000 to go into meters, and then times by 100 to go into centimeters. So I will say 500 times 1,000 times 100. And now I will see that I will have both of my values in centimeters. So what I have now is 50 million centimeters, and on this side I have 2 centimeters. So because I'm working in the same unit, I don't have to write my unit, and I know the question is asking for the answer in a unit form. So I have the same units. I know it expects me to have 1:to something. So to go from this to that, I will divide by 2, which means on this side, I will also have to divide by 2. So 50 million divided by 2 will give me 25 million units. So this means 1 unit on this map represents 25 million units in real life. So actually, grade 12s, all that this means is if you look at South Africa in real life and you look at this map, it has been reduced 25 million times. That's why all the provinces fit into one small picture. So grade 12s, thank you so much for joining us today for this session on scale. I hope you feel more confident in terms of the types of questions you can be asked, how to prepare for the questions, and how to answer the specific questions. Thank you so much for joining us, and all the best for the rest of your term and your prelim exams that are coming up.